Welcome back to our unit on environmental science. Last week, I know that we just more or less looked at some careers and some biotechnology. This week's when we're going to have an opportunity to actually get our hands a little dirty because we're going to start talking about soil. Um, I'm going to show you a picture in just a minute that's really going to help explain the slide that I have in front of me. But if you were to actually dig a hole and you were to look at the profile of that hole, which is basically just to stand back and to look at the side of it, you would see that there are different layers in a soil profile. And actually, I'm going to go ahead and if you need to copy into your course pack, you can pause there and copy. But I'm going to go ahead and go to the picture and explain this as I'm showing you the picture because I think it makes more sense. So what we're looking at here is basically this is a soil profile, and these are feet. So we're looking at how far down you're going in the actual soil whenever we're looking at a profile. Some profiles you actually see more horizons than what you're seeing on this particular one. But the A horizon is typically going to be like the top 6 to 8 inches of soil, and it's going to be normally brownish in color, typically very fertile. And the reason for that is because it has organic matter in it. You can see that there's some sort of green up here that's growing. And so as those plants decompose and as the roots are in the soil, then they actually help to create organic matter for the soil. So that is going to be our top soil layer, our horizon A, and this is going to be the stuff that's the most fertile, that's the most desirable. And you can tell there's a definite line as we get down into the next horizon, which is called the B horizon. And the B horizon typically does not have as much organic material because you don't have the roots that are digging so far down into the soil. This is what we call the subsurface layer. Typically, it's going to increase in clay content. So you can see how dark this is. It's what we call a loamy soil, and we'll talk more about loam just a little bit later on. But then you start to notice a little more red as you're getting further down. So that is going to be your B horizon. It's going to be it's going to have a pretty big influence on what you actually can do with the soil, whether you can build on it, whether you can put a septic tank on it, um, you know, whether you can work with the soil in other ways. So that subsoil is going to make a huge difference in what you can actually do with the soil. If you kind of look, and it's hard to see on this one, this is not the best soil profile, but you can see it starts to get a little lighter, and it doesn't look like it's as, like it kind of looks like it's kind of chopped up here into smaller pieces. It looks like it's more like big chunks down here. And this is going to be your C horizon. Sometimes this is also called bedrock. This is the parent material. This is where your subsoil and your topsoil eventually come from. It's going to release water to the upper soil layers. So, as water seeps down into the soil, it has to stay somewhere. It's eventually going to typically go down into that C horizon, and it will help to release that water to the upper two horizons so that things can grow in it. Typically does contain a lot larger soil particles, and that's what I was mentioning before. Like here, it looks like they're all kind of what we would call granular, which means that it would break apart fairly easily. But then the further down you get, the more difficult it would be to actually break that down. There are 3 soil textures, and so whenever we're looking at soil textures, the largest one that's pretty easy to pick out, is sand. So if you were to go to the beach, you literally can watch the water seep down into the sand because there's such large particles that the water just sinks in between those particles. You can literally pick a grain of sand out and look at one grain of sand. You can't necessarily do that with silt or clay. So sand is going to be the largest of the soil particles. If we were to kind of compare this to, let's say, something that is, every day for us, that we would see every day. If I were to compare this to the other soil particles, I would say this one is about the size of a basketball as compared to what I'm going to talk about with the other two. So think about that large size basketball, and if you filled up my entire classroom with basketballs, there would be a lot of space in between the individual balls because those grains are so large, and there's a lot of space for water and air to go in between those soil particles. The next size is silt. And if we were thinking about the size of silt in normal terms, this is kind of an intermediate size. You can't actually pick out one piece of silt with your naked eye like you can with these sand particles. If we were to think about the difference between the sand being the basketball, a silt particle would be something more like a tennis ball. So much smaller as compared to what we looked at with those sand particles themselves. And so your silt is going to be much smaller. They're going to cling together a little bit more tightly. There's going to be less room for air and water, and water is not going to move through it as quickly, because you can cram a whole lot more tennis balls into my classroom than you can cram basketballs into my classroom, just simply because of the size of them. Finally, the smallest soil texture is clay. This one is so small that a lot of times it has almost has a texture to it that feels kind of sticky, and we're going to talk about that just a little bit later on. Helps you to figure out what's actually in your soil. But it's the smallest soil particle. It holds a lot of water. It doesn't drain very well because it holds on to water so tightly. So let's think about the difference between filling my classroom with basketballs versus tennis balls versus ping pong balls. And so you can fit a tremendous amount more ping pong balls into my classroom than even tennis balls. And there's not going to be as much space in between the balls because they are so much smaller. So it can kind of be difficult to grow things in clay because it's kind of airtight. So it's not very fertile as far as root growth because it's really difficult to get things to grow really well in clayey soil. A lot of times you think about this as being a wet soil because it does hold on to water so tightly. Now, when we look at soil structure, basically we're looking at how soils actually cling together. If you were to go to the beach and you were to pick up a handful of sand, that handful of sand, if you were to open your fingers up, would run right through your hands. So those single grain soils are sandy soils that have a tendency to allow the water and the air to flow through them easily because you can actually separate out the individual grains. So when we look at sandy soils, we call that single grain structure. Granular means it's just kind of good soil for things like gardening and stuff like that. You're going to have some particles that cling together, but they're not going to be these huge, massive particles like dirt clods that cling together, because that's not healthy for anything to grow in either. So granular is kind of like what you think about whenever you just think about regular old soil that you would, like even potting soil. Potting soil itself is not it's typically not a soil. It's typically got peat and other stuff in there, but the same consistency of potting soil is what we're talking about as far as a granular type of structure. Finally, blocky. And there are a couple others. There's blocky, there's platy, there's massive, but you only have to know these three. Blocky is going to be kind of where you got a little bit more clay in it, and those particles cling together a little bit more. They have a tendency to stick together a little bit more, and they're just not as easy to break apart. So those are three soil structures. There are more, but if you choose to take natural resources, we'll talk a little bit more about the other soil structures. Basically, it's the more clay you get, the more you can actually do with the shaping of the soil. Now, soil classification, and actually I do have a couple of pictures of some structure coming up. So let me actually come back to soil classification. All right, so here is blocky structure. You can look at this and see how red it is and actually see that there's probably a lot of clay in there. But this blocky structure would have enough clay in it that it forms these little, they're not huge dirt clods, which would be more like a massive type structure, but a blocky structure is going to have some of those small, almost rock-like pieces to them. Granular is going to be, now this is an up close picture of granular. It's going to be a loose soil that is not as loose as single grain, but it's loose enough that you could actually plant stuff in. Platy and massive we didn't necessarily talk about, but you can see the granular here, the blocky here. And so those are the ones that you need to be most familiar with, and of course the single grain with the sand. Now let me go back to soil classification. So as far as soil classification, we have these different things called land capability classes. And land capability classes are based on the soil itself. Is it sandy? Is it clay? Is it silty, or what we call loamy? Does it have blocky structure, single grain structure? What is it good for? Is it on a hill? Does it have drainage problems? These land capability classes tell us what we can actually do with the soil. The best land capability class is class 1. Class 1, you can pretty much do anything with it. You can farm it, you can cultivate it, which means you're turning the soil. You can build on it, you can dig it, you can plant stuff in it. So class 1 is going to be the absolute best as far as the soil classification, because you can do most anything with it. Class 2 is still good, just not quite as good as class 1. And typically the difference between a class 1 and a class 2 might have a little bit to do with slope, or it might have a little bit to do with how well drained it is, but it's still a good soil. As you get further down towards 7 and 8, you kind of get to the point where you're having to look at what you can actually do with those particular types of soils. A class 7 typically is a steeply sloping soil. So this is going to be like your mountainous soil, and you can see that it's best used for planting trees. So that's why when you go to get a Christmas tree in North Carolina, if you're going to go and purchase one from somewhere and cut down your own tree, most of the time you do that in the mountains, because those mountain areas are not necessarily the best for cultivating other things. So these very steeply sloping mountain and hill areas, there would be a class 7, and you really can't do a whole lot else with them other than just plant trees on them. If it's class 8, and it's just not very good soil for whatever reason, a lot of times class 8 soil is going to be swampy area, and so a lot of times it's going to be best suited for things like wildlife and recreation. You really don't want to plant anything on it. You really don't want to build anything on it. You just want to let things live and grow there and have habitats there, because it's just not going to be the best soil for you to be able to do a whole lot else with. So that's soil classification. Remember 1 to 8, and there are some subcategories in there, but you don't have to learn about those subcategories. 1 is the best, 8 is going to be highly restricted. So let's get back past these pictures. So the best thing that we can do as good stewards of the environment is to think about the idea of soil conservation. And so when we're looking at soil conservation, we're trying to figure out the best way in order to make sure that we are keeping the soil where we want it to be. We're helping it to stay put, to not erode. I'm going to show you some pictures of erosion coming up in the next couple of slides. We will also, if you're a cohort A or B, we will do some erosion activities in class. We'll watch a video about erosion, and you will actually go around campus and look for signs of erosion in different places on the property. So the two types of erosion, you have sheet erosion and you have gully erosion. Most of the time with sheet erosion, you're looking at things like people walking on the same spot over and over, people driving on the same spot over and over. It just becomes worn away over time, is typically what you're looking at with sheet erosion. Gully erosion normally happens whenever you have soil that is in a flood prone area. And so you end up getting these really big gullies where the water has just washed out wherever you are and it's created almost like a little ditch. So we really want to be careful with either type of erosion, because we want to keep our soil where it is, because that's a natural resource that we need, and we want to keep it as fertile as possible. So there are some things you can do in order to help conserve the soil, and one is no-till planting. And so basically, whenever you're doing no-till farming, you essentially are not actually going to plow the soil or turn the soil over whenever you get ready to plant it. The crops are going to be planted directly into the residue of what was there before. Something like a grain drill can help this to be able to happen. Most of the time you think about going out and actually driving the tractor over it, getting the soil prepared, getting the soil soft, turning the soil over, but in no-till you actually don't do that. You're just planting your seed directly over where the residue was from whatever you had planted there last. Conventional tillage is actually going to be where you do disturb that soil and you turn it and you get it ready, get it soft, get some of the weeds and things out of it, and get it ready for planting. That's what we do with conventional tillage. There's more likely to be some issues with erosion there, just because you are exposing the soil to the upper layer, and so because of that, if it rains, you're more likely to lose some of that soil. Conservation tillage is going to basically be a combination of some doing some tilling, but also doing some no-till methods. And so there are different levels of how much you actually would disturb the ground when you get ready to plant something. You can see here, this is an early stage of sheet erosion. Probably what has happened here is, this is a sloping area. You can see that there's a little bit of a slope to it. The rain has most likely run over this area quite a few times. Could also be an area where you have had a lot of traffic, or you had something sitting for a while. Those things tend to cause erosion issues as well. So you've got, in this particular picture, you're looking at sheet erosion. A lot of times with sheet erosion, you may see that the soil is kind of even accumulated along a fence line, or if you have a silt fence or something like that, sometimes you actually can see where the erosion has come down the hill. It's basically all coming down at one time, in layers versus in one big gully, which is what you're going to see here. So this is a severe example of gully erosion, and you can see that the water has just run and it has dug ditches into the ground. Another picture of gully erosion right here. So both things that we need to be aware of, both things that I want you to think about as you're walking outside. Take a look and see where you see areas of erosion and issues of erosion, whether it's sheet or gully erosion. Cohorts A and B, you will be doing some of that in class next week, so make sure that you can recognize the difference between the two, because hopefully you'll be able to go out and find some examples of this on campus. Actually, if you can't find any examples of it on campus, that's probably a better thing, but I think you probably will. So until next time, that is soil, and next time we will be looking at wildlife management.